This is Algebra 2, Lesson 13.1. We're looking at right triangle trigonometry or right triangle trig, beginning on 769. Using trig relationships to evaluate trig functions of acute angles. Remember what acute angles are? That's angles that are less than or smaller than 90 degrees. If it's a right triangle, remember there's three angles in it, and all three angles have to add up to 180 degrees. So if you have a right triangle, meaning one of them's 90 degrees, you can't have something larger than 90 degrees. And that's why when you're talking about right triangle trig, you're always talking about acute angles. We have three definitions to start. The first one is what solving a right triangle means. What that means is finding all side lengths and all angle lengths, or talking about the missing ones. Remember, there are 6 parts of a triangle. Remember, it's called a triangle because it has three angles, but it also has three sides as well. So you have one, two, three angles, and you have one, two, three sides. So you have to fill in all 6 parts for it to be considered solved. The other two definitions are called an angle of elevation and an angle of depression. All that's talking about is when you're looking at something, you'll typically do it with the real life problems that go with it. An angle of elevation is if you're looking from this perspective right here, and you can see that the angle is elevating. An angle of depression is the exact same thing, but the other way. So you're looking from this perspective right here, the angle will look like this. So still everything's the same, but that's your angle of depression going that direction there, unlike your angle of elevation, which is going up. So it's just talking about a higher object and a lower object. It's a real simple concept. But if you see those two terms, angles of depression or angles of elevation, that's what it's talking about. A right triangle definition of trig functions. So when you see this symbol right here, it's called theta. If you are planning on taking advanced math, and if you're planning on going to take college math, get used to that symbol right there. You're going to see it a lot. You won't see it a whole ton in Algebra 2. Just one portion of what we do in Algebra 2. But once you get in advanced math, and again, when you go start taking college math, everything talks about angle theta. That's just like everything in Algebra and Algebra 2 talks about x being something. Theta is the new x, basically. So get used to that symbol right there. So let theta be an acute angle of a right triangle. The 6 trig functions of theta are as follows. So most of us are familiar with the first 3, sine, cosine, and tangent, these 3 right here. Okay. There's a mnemonic device that people came up with eventually, Chief Sokotoa, that makes people remember the order of each of these for the formulas. S-O-H, C-A-H, Soka-Toa. And I like to enunciate the difference to where it doesn't sound like you're saying the same thing for Soka. So Soka-Toa. And they're all in the same form. It's the first letter is equal to the second letter over the third letter. So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Again, that's just an easy way to remember those 3. And again, most of y'all are already familiar with that. And you remember these 3 trig functions. These are the 3 functions on a calculator that you see right above the parentheses keys and all of that on most of them. Sine, cosine, and tangent. The 3 trig functions that you are probably not familiar with are the next 3. Cosecant, secant, and cotangent. Now let's go this way with it. Tangent and cotangent are the 2 easiest ones to remember because they both have tangent in them. So if tangent is opposite over adjacent, then cotangent is just adjacent over opposite. All you're doing is taking the inverse of it, or you're taking reciprocal and you're flipping it. The other 2, cosecant and secant, are the reciprocals of sine and cosine, respectively. So all you do is you find something that you're familiar with, like sine, and you flip it to call it cosecant. Same thing with cosine and secant. Now, the mistake I see students making with this is they want to pair sine with secant, and they want to pair cosine with cosecant since they both have the co in them. Remember, make sure you don't do that. just find the easiest way to solve triangles or to do this, what we're about to do it for example number one in a second, is to find sine, cosine, and tangent, and know that cotangent goes with this one, and then do cosecant, CSC, with sine, and then secant with cosine. Just pair those three with the other three, and you won't make a mistake because you know, and you've used, and you even if you have to remember, you know how to do sine, cosine, and tangent based on SOHCAHTOA. The abbreviations opposite, adjacent, and hypotenuse represent the lengths of the three sides of the triangle. Note that the ratios in the second row are the reciprocals, and that's what I just said a second ago. All you do is flip it. That is, the cosecant is 1 divided by the sine. So it's just the cosecant of theta is equal to 1 divided by the sine of theta. The secant is 1 divided by the cosine of theta, and the cotangent of theta is equal to 1 divided by the tangent of theta. Another thing I see students do from a mistake standpoint is, if you look on your calculator, if you look above sine, cosine, and tangent, you'll see the inverse of sine. You'll see sine to the -1. You'll see the inverse of cosine, and you'll see the inverse of tangent. You're not using those keys for this, because if you hit those keys, you're not going to get the same answer as if you do 1 divided by those. I'll show you when we use those keys when it's time to do those. Example number one is evaluating trig functions. It says evaluate the 6 trig functions of the angle theta. Now, when we're talking about the angle theta, remember there are 3 angles. We're talking about it from this perspective right here. So there's an adjacent, and there's an hypotenuse, and there's an opposite that are different if we were looking at a different angle. When we're looking at it from this angle right here, our opposite is the one that's directly across from it this way. Our adjacent is the one that's next to it here, that's not the hypotenuse. And you know that the hypotenuse is the longest side of the 3. So the length of the hypotenuse in this case is equal to the square root of 8 squared plus 15 squared. That looks a whole lot like our bell word did. Remember, that is the Pythagorean theorem. That is the same thing as, and it's written in this form right here, a squared plus b squared equals c squared. Okay. When you learn the Pythagorean theorem, you probably learn that in reverse. You probably learn c squared equals a squared plus b squared, but it's all the same thing. Okay. In this case, since you're trying to find what c is and not what c squared is, you need to take the square root of both sides. So that's why it's written as the square root of a squared plus b squared is equal to c squared. So the square root of 8 squared is 289. That's when you put them together. The square root of 8 is 64. The square root of 15 is 225. When you put them together, you get the square root of 289. And then the square root, what number times itself is 289? We know, since this is an even root, that it would be 2 values. It would be both, since it's an even root 2, it would be both 17 and -17. We talked very briefly last week about something called extraneous solutions. What is wrong? Just look at this and answer this question to yourself. What is wrong with the number -17 as a distance of the hypotenuse? 17 mathematically works, and so does -17. But remember, distances cannot be a negative value. So even though 17 and -17 both work, -17 in this case would be considered an extraneous value. You would focus on only the positive 17. When you're doing the trig functions, now that you have a value right here, 17, when you're doing the trig functions of theta, you're going to do them as sine, cosine, and tangent. Sine, according to Chief SOHCAHTOA, is SOH, so opposite over hypotenuse. The opposite of theta, in this case, is 8, and the hypotenuse we just found is 17. The cosine is CAH, again, which is the adjacent over the hypotenuse. And the adjacent, the one next to theta, is 15. Over the hypotenuse is 17. So those are 2 of the trig functions, sine and cosine. Those were the 2 of the 3 original ones that you're familiar with. Tangent is the third one that you're familiar with, TOA, T-O-A. So tangent is the opposite over the adjacent. So opposite in this case of theta is 8 over the adjacent is 15. Again, once you have those three trig functions, and the way this example is set up on your sheet does not facilitate what I'm going to say next. Once you have these three trig functions, remember, it is the reciprocal of the other ones. So sine is paired with cosecant. So the cosecant is next. Cosecant is the reciprocal. Instead of being opposite over hypotenuse, it's hypotenuse over opposite. So again, hypotenuse we know again is 17 over the opposite, which is 8. That's the cosecant. The secant is paired with cosine. So cosine, you know, CAH would be what cosine is. So secant is the inverse of that. Hypotenuse over adjacent. The hypotenuse, again, we know is 17. 17 over the adjacent, 15. And the cotangent pairs with the tangent. That's the one that people usually don't make a mistake on. You know that the tangent is TOA, the TOA part of SOHCAHTOA. So it's the inverse of that, adjacent over opposite. So adjacent is 15 over 8. So those are your 6 trig functions of this triangle. Given 2 sides, we had a side angle side, so we were able to solve what the rest of them are. And that's what we'll get to on the next example. On the back, however, right now, give the 6 trig functions of angle theta right here. You ought to be able to do this real quick. Take about 45 seconds on this. Easiest way to do the 6 trig functions. Do the sine, cosine, and tangent because you know that SOHCAHTOA will give you those. And then pair them. Notice I have them paired across from the cosecant, secant, and tangent. So the sine is the opposite over the hypotenuse. The opposite of theta is the one that's directly across, 12. So it'll be the sine is 12 over the hypotenuse, 13. The cosine is the adjacent over the hypotenuse. So the adjacent is the one that's next to it that's not the hypotenuse. In that case, the one that's next to it is 5 over the hypotenuse, 13. And then the tangent is the opposite over the adjacent. Opposite is 12 over the adjacent, 5. Remember, the 3 that are paired with sine, cosine, and tangent are the inverses of each one of these. So the cosecant is just the reciprocal of 12 over 13. It'll just be 13 over 12. The cosecant is the reciprocal of 5 over 13, 13 over 5. And the cotangent is the reciprocal of 12 over 5, 5 over 12. Those are your 6 trig functions of this triangle. Again, you should have been familiar with the first 3. The next 3, while they may not be as useful, and that's why they're taught second, do have their uses. They're just the inverse of the first 3. The first checkpoint tells you to evaluate the 6 trig functions of both angles. So we have 2 angles. We have a 45, 45, 90, and we got a 30, 60, 90. But we have all 3 sides of each of them given to us. So we'll just call this triangle number 1 just to make it simple. And we'll call this one triangle number 2. So take 1 minute or take another 45 seconds and give me the 6 trig functions of the first one. And then we'll do the second trig functions after that, 45 seconds. Again, do sine, cosine, and tangent first. Do the ones that you're familiar with. So when you're talking about the six trig functions of the angles shown in the right triangles, we'll do it. Both of these are the same. Both of them are 45 degrees. So the sine of 45 degrees is the opposite over the hypotenuse. So your sine would be 1 over the hypotenuse, the square root of 2. The cosine is the adjacent over the hypotenuse, again, 1 over the square root of 2. And the tangent is the opposite over the adjacent, 1 over 1. So having those three, all you have to do for the other ones is flip them or use the reciprocal of them. So the cosecant, instead of being 1 over the square root of 2, is the square root of 2 over 1, which we know is just the square root of 2. We're just writing them the way they are right now. The secant is the inverse of 1 over the square root of 2, again, the square root of 2 over 1. And then the cotangent is simply 1 over 1 when you flip it like that. So of a 45, 45, 90, and when you start doing trig functions where you're filling out the entire trig circle, um, you'll start to get used to these numbers, the square root of 2 and 1 over the square root of 2 and 1 over 1 and so on and so forth. For the other one, again, it's a 30, 60, 90. So there's actually, instead of having just 6 trig functions, there's actually 12 trig functions of this one. So if we do it of this angle right here from 60 degrees, its sine is the opposite over the hypotenuse, the square root of 3 over 2, which means its cosecant is the reciprocal, 2 over the square root of 3. Notice all I did was flip that. The cosine is the adjacent over the hypotenuse. It's adjacent, and the reason I circled 60 is to where we don't look from a different perspective, is 1 over the hypotenuse, 2. Its secant is the reciprocal of that, 2 over 1, which we know is simply the number 2. And the tangent is the opposite over the adjacent. Opposite of 60 degrees is the square root of 3 over the adjacent 1, which again, when you use the reciprocal, is 1 over the square root of 3. That was from the perspective of 60 degrees. When you take the perspective of 30 degrees, all of those numbers are going to be different. So from this perspective here, the sine is the opposite over the hypotenuse, 1 over 2, which means its cosecant is the inverse of that, the square root of 3 over 2. The cosine of that one is the adjacent over the hypotenuse. Cosine is square root of 3 over 2, which means its secant is 2 over the square root of 3. And the tangent of that one is the opposite over the adjacent, 1 over the square root of 3, which means its cotangent is, when you reverse it, the square root of 3 over 1. There's a lot of work to do with these, but again, it's very, very simple work. Tomorrow we'll pick up with example number 2.